Good morning. I'm Arch Woodside, and this is lesson 7 in fuzzy set qualitative comparative analysis, the use of the software. And today we're going to look at necessary analysis. And when you submit a paper, reviewers who are familiar with fSQCA typically want to take a look at a table on your necessary analysis. So I'd like to show you how to do that today. And let's go ahead and go through a couple slides on this. And so necessary conditions analysis, all right? And when we talk about necessary conditions, we're talking about whether or not the XY plot of cases on the antecedent condition. And remember, typically this is a single condition, a single antecedent condition. It could be, for example, price, and Y would be not purchase, the negation of purchase, for example. And so all the cases would look something like this, that high X gives you high and low Y. So this is a situation where low X, there's nobody that is high Y on your outcome condition. But if you look at this type of a distribution, you have low Y with high X as well as high Y. The example comes to my mind typically is, say you're a heterosexual male and you're looking to marry a woman. And so a woman is being a woman is a necessary condition, but it's not sufficient. You'd like to see additional ingredients in the woman that you would marry, besides the fact that she's a woman. So it's necessary but not sufficient, because you have cases that are low in Y that are high in X, where X is the condition of being a woman. And so this is in comparison, for example, of where you have this. Let me draw X down here and Y. A necessary and sufficient condition would be all the cases would line up like this, and it would be a symmetric relationship, that high X gives you high Y and only high Y, and low X only gives you low Y. And so looking at just the high scores above 0.50, that we're predicting, we have 100% accuracy. So this would be necessary and sufficient. No, and this would be empty. This is empty, this area, and this is empty here, empty here. So that's the general proposition of symmetric analysis. The additional analysis that we could look at, and let me mention what it is, and this would be sufficient but not necessary. So here's X, simple X, and this is Y. And all the cases pretty much line up over here in this area of the XY plot. So so you have some X's over here, you know. And so if you're high in X, you're going to be high in Y. So it's sufficient, but it's not necessary, because there's also cases that are low in X and high Y. But you don't really care about that. You're just finding out here that if you're high in X, you're going to be high in Y. And typically that's what we expect from a complex statement. We don't typically get this from a simple condition, a singular X, but we will get this from a complex X, where we have, say, 4 or 5 single conditions in the complex statement. And here, for example, we're going to have cases down here. If we have lots of cases down here, we really don't have much in the way of predicting anything. So our aim is to get rid of cases that would be high in X and low in Y by adding in a few conditions. So say, for example, you're looking for, say you're a male heterosexual and you're looking for somebody to marry, you would add in about 5 conditions. And so that gets rid of the women that don't meet the that don't include the conditions that you're looking for. So, for example, if you're looking for a woman of a certain age level who has a similar educational background and who likes you, which sometimes can be difficult for us crusty people, and you actually find her beautiful. So those would be all conditions, and you end up with, say, 4 or 5 high Y and nobody who's high in X and low in Y. So that would be sufficient, but not necessary. All right, so let's go on and take a look at, this is the output, and I'll show you the output in a second. I'm using the data from our pricing and PAL and expertise experiment that we've been using in this course so far, and so we have consistency and coverage, but these are actually listed backwards in the output, and so that's why I have an X for them. To be necessary as a antecedent condition, you should have about the benchmark is 0.9 in consistency, 0.9 in consistency, very high consistency, and the benchmarks here for consistency, this is actually consistency, don't approach 0.9 at all. And if you look at all these for, and this is for buy here, I'm going to put a circle around this. This is for buy. All right. And over here is for not buy. You actually do it twice, buy and not buy. And this is what your table looks like. And if you want to see it, a particular antecedent condition on your output buy, you can always graph it, an XY plot. And we'll do that in a second. We'll graph the XY plot for, say, price or PAL. And but looking at this, expertise has a consistency of 0.75 here, and let's see, where am I here? Right here. You see the 0.75? So that's near the benchmark. And so what this indicates is the odds are about 3 to 1. If you give an expert message, you're going to buy here. And if you give an expert message and for not buy as the outcome, the consistency is 0.35. But what is high here, as you would expect, for not buy is no expert message. No expert message indicates to some level, not sufficient for accurate predictive purposes, but it's 0.68 the consistency level. So we're going to actually do that in a second now. And what I did here, what I just mentioned is I graphed it in terms of, this is for buy right here, and this is for price. So this indicates that we have 0.58, which is not a very good model for consistency. Remember, the benchmark is 0.80. So we have a lot of cases that bought with high price, but we had a lot of cases that did not buy with high price. So we want to do better than this. So we want to get rid of these cases. I shouldn't say that, but we want these cases to shift to the left by adding in additional conditions so that our consistency level gets up to 0.8 or 0.85 or 0.90. And here we look at buy and expertise, where it's 0.75, which is a much better consistency level, but it still doesn't reach the benchmark of 0.80. And so it's always nice to, and you typically would not have the space in a paper to report all your XY plots. So in your necessary analysis. So typically you put it in terms of one table. So let's go ahead and take a look at the data and do the analysis here. All right, so this is what you want to do. You want to click on analysis. Pull up your data, and here's the data that we've been looking at. The 180 cases, and click on analysis. Click on necessary conditions, and that's going to bring up this information where you put down the outcome that you're looking for, which is the buy condition, and the single things that you're looking for would be the antecedent conditions would be price and not price, PAL, and cancel. Let's just try that again. We're just looking at single conditions, fuzzy truth table. I don't want that. I want the necessary conditions, and we're predicting buy. All right, and we want price, and then we want not price, the negation of price. Then we want PAL and not PAL. And we want expertise and not expertise. Okay, and so then we run that. And let's find the output. Here's the output. So this is the outcome is buy, and so you would report this in a table. So you'd make a copy of this, and then put it in a table in your report. Now I would round off the decimal places to 2 decimal places. So notice for expertise, and this is actually the consistency, and this is coverage. So you want to turn these around, because remember, for expertise, the consistency was 0.75. All right, now we do the same thing for not buy. You have to include not buy in your table. So you have 2 outcomes that you're looking at. And so for analyze necessary conditions, you come up with not buy. No, that's the wrong one. You want it to be calibrated. All right, by, not by. This is not by. All right, then you have price calibrated, and then price, not price, and then PAL, not PAL, and expert, not expert. Then you run, take a look at the output. Down here is the output for the second analysis. This is not by, right here, not by. And the thing that works, and over here, this is actually the consistency. So you'd switch these around, and looking at consistency, the thing that has the highest accuracy, and it's 0.68, is for not expert. And that makes sense, but and for none of the conditions, though, you approach 0.90 in terms of high necessity for the condition being present. So, and then that's it in terms of reporting your necessary analysis in your paper that you write up. And you want to do all that for your singular antecedent conditions. All right, so I want to go back to the slides and mention that and notice that you might want to do your XY plots on the singular conditions. This is the complex antecedent condition of expertise, not price, and PAL present. And if you recall from our prior lesson, this model works very well, 0.932 for consistency, and coverage is pretty decent at 0.257. So when you have a consistency of 0.93, you're going to have odds like 7-to-1 that if you're high on X, if this combination or recipe of singular conditions occurs, you're going to end up with a purchase most of the time, over 6-to-1 odds that you'll have a purchase. And that's what you're looking for. So this is a situation of high sufficiency, but not necessary. And that's what life is all about, that you end up with high sufficiency, but not necessary in terms of a useful model at case level analysis. So the takeaways today are that many journals are going to require you to report your necessary condition analysis of singular conditions. So you got to be prepared to do that. So include a table of the analysis in your paper. And I want to stop there, but I do want to mention, as a teaser for lesson 8, we're going to look at general templates for accurate case outcome modeling in consumer and management research. Here's an example of a more complex model. We've been talking for several lessons now about price, PAL, and expertise. But this is a situation of consumers going into a retail service store, and here we're talking about women having their hair done and a facial in a health spa, and that's also a beauty parlor, and where you have multiple outcomes, and you have the consumer evaluating the establishment on several conditions, such as the decorations of the architecture of the establishment, then the people quality, background music, product displays, and then the actual service delivery. Section B of this graph, and then on the left are some demographics. And typically, when people do studies in consumer research, they forget about including the demographics in modeling. I think that's a big mistake. You have a much richer, fuller analysis and research if you include demographic configurations. So one demographic configuration, for example, if you take me, I would be highly educated, an old male, gender would be male, highly educated, old guy, retired, and so those are on 4 dimensions. But if you think of high, medium, low on these dimensions, or male, female, and then other in the middle, people who don't identify as male or female, part of our woke culture today. So in 3 occupational status levels, for example, and 3 educations and 3 age levels, or if you want to say 5, that's okay too. But you quickly come up with 81 or even more combinations or configurations. So you want to work backwards when you do this, and we'll talk some more about this, and we'll actually do some data analysis in lesson 8, and we're going to do that also for management research too, where we're looking at templates to do management research of management performance, where you have multiple outcomes such as sales growth and growing and declining markets. And we'll talk some more about this at our next meeting. And we can also study entrepreneurship effects on quality of life and macro cultural studies using asymmetric modeling. And this is a tourism type of research, a general template using Hofstede cultural values of individualism, uncertainty avoidance, power, distance, and masculinity. And we'll talk some more about that briefly in lesson 8. And this is using Schwartz's cultural dimension configurations, and he uses 7 cultural dimensions. And Schwartz has been shown by several different researchers to work better than Hofstede. Interesting, though, Schwartz and Hofstede never really approached their data on country level by looking at configurations. They use symmetric analysis, which I believe is a major mistake in their research, empirical research work. So that's it for today, and I look forward to seeing you for lesson 8, when we actually work with a more complex data sets than we've had up until now. Take care, and until next time, bye now.